This is part 2 of the 8.2 video notes. So to start off, we are going to define what a numeric expression is. Numeric expression, now the key word there is numeric, which means number, okay, that there are numbers in the expression. So this type of expression only contains numbers and operations. So there's nothing else in a numeric expression except numbers and operations. So an example of this is if Sam, that's supposed to say Sam. So you can cross out the E if you want. This is supposed to say Sam. Oops for that typo. Okay, Sam ran 6 miles each day for 9 days. Write a numeric expression to represent how many miles he ran. So for this problem, I don't care about the actual answer. What I want is a numeric expression. Remember, an expression is something that does not have an equal sign. So I don't want to know about what it equals. I just want to know what the problem would look like set up as an expression. So Sam ran 6 miles each day for 9 days. One way we can write this is every day, if he runs 6 miles every day, right? Wouldn't that be just 6 plus 6 plus 6 all the way until we get to 9 times? So you add 6 together, okay? Now, if each day is grouped into 6 miles, we can also group this as a multiplication expression as well. And so how would you write 6 plus 6 plus 6 plus 6 9 times in a multiplication problem, right? We want 6 nines, or we want 9 sixes, which means that we want to take 6 and multiply it by 9, just like that. Okay. So let's look at the words that have to do with operations. Now we have our first one is add or plus. Okay, these all, hopefully, you should have heard of all of these words that we're going to talk about. Add and plus, what this means is that we are going to put them together. Okay. This is, we're going to take two numbers and put them together. Now the sum, the word sum is related to adding and plussing, but the word sum means the answer. This is the answer to an addition problem, right? Now when I say to add something means to put them together, but the sum of something is referencing the actual answer to those two things put together. Okay, let's look at subtract and minus. This means to take away from. Oops. And then the word difference means the actual answer to a subtraction problem. An actual answer. When we multiply or we times something, that means that we are grouping repeatedly. So we can call that repeated groups, right? It's repeated groups. Just like the example above, right? It's 6 times 9. That means that there's a group of 6 that you're repeating 9 times. Now the product would be the answer, okay? The answer to the multiplication problem. So 6 times 9 would represent the repeated groups, but 53 would be the product, the actual answer. Okay. When we divide, we are separating, that's spelled wrong, separate into groups. So we're separating things into smaller groups, and the quotient, the word quotient means the answer to a division problem, right? It's the actual answer. When we think about this as let's look at this example of how these words make a difference in like a word problem. Okay, now below here we have 4 plus 6 times 7. So what we're going to do is we have 4 plus means to put them together. So we're going to add the 4 and the 6. And then times 7 means that we're going to make a repeated group of 7, which means we're going to do times 7. Okay, so this would be a representation of that. Those two are the same thing. Now, the sum of 4 and 6 times 7. Now, the sum of means I care about the actual answer to the sum of 4 and 6. Okay, now when we take 4 and 6 and add them together, we want these things grouped together because I don't care about like them just plussing each other. I care about the actual answer, the sum of these two things. So we're going to group these together with parentheses. And then we're going to multiply the entire sum of 4 and 6 by 7, like that. So even though these all have the 3 of the same numbers, they will get you different answers because one is grouped differently than the other.